Well, this is why I'm recording it. I'm recording it because there's going to be a lot of people coming and going today. But this is why I'm recording it, so that you can watch it after. Okay, implicit differentiation. What? We did 2 yesterday. Oh yeah, 2 is very short. 2 is more like an extension of 3.1. So it was basically 3.1 and 3.2 were chain rules being shown different ways. 3.3 is going to be implicit differentiation, which sounds more difficult than what it means. That's a bad sign for today. Rexy is down. Alright, now it's okay. We have never called them explicit functions previously. But today they're introducing implicit differentiation. Okay, I know today's kind of a mess, but I need you guys to focus when you're in here, because otherwise you're not going to learn any of it and the test is going to go badly. So I know it's difficult with people coming and going for pictures, and or you knowing that you might have to leave for pictures. Focus as well as you can. And it is why I'm recording it, so that if for whatever reason your brain is just not having it today because you got to come and go, you can watch this later. Explicit functions is when it's solved for a letter. So explicit is what we normally work with. Like y equals. Okay, that's explicit because it says y equals. That is virtually every equation we work with. We don't ever call them explicit. But for whatever reason, as soon as we go to implicit equations, then they definitely use the term implicit. And for the most part, that's what kind of scares everybody is the term. So implicit functions is when it is not solved for a single variable. Probably the easiest and most common example is a circle. A circle equation isn't solved for x and y because a circle isn't a function. Most of the time, explicit notation is function notation. So if you have something that's not a function, it can't be written explicitly. So let's say circle, circle with a center at 2, 4. With a radius of 3. Okay, so that's implicit. We're going to be doing derivatives on equations that aren't solved for a single letter. That's basically what today is. Now, the notation, it's not great. It's a lot of dy dx's. So let's look at the first one. It says find dy dx. They don't traditionally write y prime for implicit notation, but if you want to write y prime, go for it. Okay? So find dy dx for xy plus y equals 8. Well, what we are going to do is we are going to take the derivative of every single term in the entire equation. And that's actually what we do every time anyway. Like, you just never really looked at it that way. If our equation was y equals something, well, we did take the derivative of the entire equation, just the derivative of y is y prime. So Okay, X, Y. Zara? No? Okay. What?
Donuts.
Did you walk in there and steal a donut from Cow too?
Steal is a very accusatory word.
More importantly, you didn't grab a second one.
So,
For me.
I borrowed it, and there was only one left.
But you didn't borrow
And
it from me.
But I split it with Rick. I'm willing to give you some.
No. You're good, you're good.
Oh,
I mean, I'm not that, just not that hungry.
all right, that's where we're at. Perfect.
Nice.
And it looks like you're missing some here as well.
Oh, yeah. Yeah, yeah, well, everybody's already been getting up and leaving and coming. It's a good day. Oh, yeah. Yeah, I don't know why I keep calling you Zara.
It's like Sarah with his name.
Yeah, no, I even have that written down on like every sitting chart. I don't know. Maybe I've just heard that, maybe I've heard that pronunciation many times before, so I don't know. I have zero reason to think so. Okay. Any thoughts? Nice. That's perfect. That's what I was hoping you would bring up first. I actually wasn't like expecting you to give me the derivative of everything individually. Okay, good. So that is exactly what we're doing. We're gonna take the derivative of every term. Now, if you want to write it out, go for it. Otherwise, a lot of people just get lazy and put it in the front and then think of it as like distribution. You're not distributing it, but that's how most people think of it. Okay, derivative of xy I'll do last. What's the derivative of 8? 0. One inch? What's the derivative of y? Perfect. Okay, now I need to do the derivative of xy. Have you guys figured out by now why I wanted to wait to do that one last? Product rule. Yeah. It doesn't matter that they're different variables. They're being multiplied and they're variables, so we have to do product rule. Okay, so product rule of xy. First times the derivative of the second. So derivative of y we already went over as y prime. Plus second, which is y, times the derivative of the first, which is 1. Now, if you want to put a parentheses there, just for your mental sake, to know separate and go for it, don't necessarily need to.
Well, wouldn't the derivative of x be x?
It is,
Oh,
but x prime is 1,
okay.
but y prime is not enough. Now, which seems stupid, right?
Yeah.
The reason for that, when it specifically says find dy dx,
It's saying find that x is your variable.
the variable on the bottom is the
Okay.
focus. So correct. If x is our focus, then the derivative is 1. And then every other variable, we just basically pretend we don't know how to do. If y was our focus, then y prime would be 1. Every other derivative would be prime.
Okay.
Yeah, it's kind of weird.
Okay.
We do get to that, but not yet. Okay, so I've got xy prime plus y prime equals 0. We have multiple options at this point. Our goal is to find y prime, because that's dy dx, at the point 3, 2. Anybody have any, question, go for it.
How do you know you're looking for y?
It says so. Find dy dx.
That means y prime?
Yes. dy dx, y prime, f prime of x, f prime, they all represent the same information, usually used differently. Now, in the past, I have used dy dx on implicit notation, but I have definitely seen that students get really thrown off by that, even though it's the same thing. So I've been trying to write y prime the last couple of years, and I feel like that's gone better for whatever reason.
This is explicit.
Implicit.
This is implicit.
Explicit is what we did every problem before this.
Oh, look at an equal sign.
They all have equal signs. Explicit means it's y equals, like it's solved for a variable. These, the variables are all mixed together, so that's implicit. But when we get to the end of the problem, we're still finding y prime. Who should we go with? Why are you on your phone? Good, help me out. How do I solve for y prime? Whoa, phone usage meant that you already knew how to do this problem and you were done with it. This looks like an illegal phone usage.
Wait, so it's legal to use your phone?
Thoughts? Do you want me to help you in a certain area?
Yeah.
Okay, it says find dy dx, which means we wrote y prime instead of dy dx. So at the end of the problem, I want this to say y prime equals something. How do I do that? I can move this up if it helps. Probably doesn't help, but how do I solve for y prime? Oh, go ahead.
You subtract y.
I would subtract y because it is the only term without y prime. And then xy prime plus y prime would equal negative y. Does anybody remember how to get y prime by itself when it's in multiple places? Factor it out. Okay, so now y prime is going to be x plus 1 equals negative y. Y prime would be negative y divided by x plus 1.
Couldn't you just plug in numbers first?
Could have, definitely.
Would you have to simplify it more? Or would that be a final answer?
Definitely not the final answer because we didn't answer what they asked for. So this would represent the instantaneous derivative at any point.
Alright, but if it didn't say at 3, 2, then it would be a final answer.
Yes. So because it does say at 3, 2, we're going to have to plug in 3, 2. We could have plugged in 3, 2 at any location. Basically, from this line on down, we could have plugged in 3, 2. Some people prefer that, some people it confuses them. So I figured I would do it this way to show the normal way.
So like notation wise, once you do that derivative, like y prime is like what you wrote is all you need to do.
If it asks you for the derivative, then that's the implicit derivative.
Well, I mean, like when you're like writing out the problem, when you're doing the work, like notation wise, do you need to like have dy dx anywhere? Or,
That's a
can
good
you-
point.
Or can you? Is that acceptable?
I would assume it's acceptable
Because it's like
because they stand for the same thing.
okay. So as long as you like are
Oh,
like,
you found another one.
if you're doing like the
Yeah,
line-
wait, did you find it in the garbage?
You know, some questions are better left unanswered.
All right, it looks clean.
It is.
I see some random sprinkles though, so it's not totally clean. We'll just hope those are sprinkles. We're gonna do good. Thank you.
It's tough to learn when they're doing some.
Do you not have a class?
Well, you wouldn't know it, they're all taking pictures.
Really?
Apparently, every single person of mine is like.
National Honor Society?
So they claim it.
Wait, why isn't my class all National Honor Society? Why did you get good?
Yeah, everyone has the line.
I like how you think I care.
So if you're solving and you have y prime in your work, you don't need to have like dx.
No, ddx is notation to take the derivative. dy dx is notation saying that that is the derivative with respect to y, which is the same thing as y prime.
Okay.
At what point do you
I'm not gonna take points off for it. I don't know if that's what you were asking. AP, I'm unsure of. She was saying, if it says find dy dx in the instructions, would it be wrong if you were at y prime? And I bet on the AP test, they probably would be particular enough that if it says find dy dx, you have to write dy dx. Okay, so x32. I'm gonna plug in the 2 for the y. Come on. And then the 3 for the x. And so my slope on whatever this equation is, I'm gonna guess it's like hyperbola, is gonna be -2/7. Now, on implicit functions, they traditionally have to give you an x and a y value for the slope. And then the reason they do that, like if you think of a circle, they can't just give you a single x value. If they ask you to find the slope of a circle at x equals 2, well, it's got 2 slopes. So you would have to have a specific point to find slope on. Yes, did I do it wrong?
Would it be 3 plus 1? 3 plus 4?
I think you're thinking 3 plus 1
It's
was
just
4.
-1/2.
I didn't even write 3 plus 4, so I don't know why this is an issue.
I see no original marks.
Yeah. I have no idea why I wrote 4.
I think you're thinking 3 plus 1 was 4.
I probably did
You
the
know I
math
put
in my
it
head.
together.
Could have been. Very well could have been.
We both saw. Yeah, he's just the one that spoke up.
Yeah, no, you guys need to do that all the time, because trying to do complex math like adding and talking at the same time is tough. I know not everybody was even here when we did this problem. Does somebody want me to go over like any particular part of that line or parts of that? Yeah, I'm not gonna go over all of it again. This is why I'm recording it. I can go straight to the second one if you want. I just didn't know if there was something in the first one that felt off. Okay? Mikkel, can you help guide me on the second one? Says find, actually it doesn't say find dy dx, it just says differentiate.
So, I will get the derivatives, right?
That is what it says. Oh, this is good. I didn't eat breakfast today, so this is needed.
So if it's not dy over dx, so then what would that, if I get the derivative of x, would it just be nothing?
You what?
It would still be one?
Derivative of number is 0. Like over here when we did the derivative of 8, that was 0. So the first line you're traditionally going to write is you're going to write the line that says you're taking the derivative. And all that does is tell whoever's reading your work what you're doing. So you kind of just said it out loud, but that's what you'd have to write down to say what you're doing. And same as over here, if you don't want to rewrite it, just do that. Derivative of x is 1. Maybe I'll do the other parts again because those are easier. First, derivative of 2, 0. On the test, I will find that this is the most common mistake. You're going to be so worried about doing the other parts of the problem that the common mistake is to just rewrite it. I get why, but it ends up being a common mistake. How about the derivative of -2y squared?
Well, you bring down the 2, right?
You do?
And then just times 2y.
It's power rule. So it would be -4y to the first
Oh.
times y prime. Because it's chain rule, and you treat the y like a u. Yes, we heard you all the way down the hall. which was not shocking to me. Stephen, you feel confident enough about doing product rule on 3xy? Oh, you're even coming up for it? Oh, all right, sold. Now we're doing this while he's writing stuff. Wait, what the heck are you writing? What are you writing? Oh, you're doing product rule. Gotcha. I think, right? You don't know what you're doing up there? So traditionally that would be labeled F. And the main reason you wouldn't want to label it Y is because there's Y's in the problem. Yep. That's why I was a little thrown off if you were doing product rule. Okay, while he's writing that, my goal for today is to go over what implicit differentiation is. Basically exactly what we're doing now. Tomorrow, we'll go over kind of like the details of the weird parts of implicit differentiation. And then my guess is we'll probably be able to finish the whole section because the questions don't necessarily get more difficult. The difficulty lies in the fact that they're different variables, and once you catch on to how the different variables work. The difficulty isn't in the information being thrown at you. So tomorrow like we'll go over how to do a second derivative for implicit differentiation, things like that. Are you looking at me for help or what? What do you want to know? So far, yeah. Like that's perfect for the portions of the product rule. That's what you're asking about? Yeah. Yep. Have confidence. You got this. Oh, definitely a little bit large for fitting in that little space above it though. Why are you going to come in here and ask about previous questions for the part you weren't here for? I believe I had a method in place for when people were gone for pictures. This is why I expected today to go so difficult, because you might be gone for parts you need to see, so it is why we're recording everything. This is taking a long time. You had the problem done forever ago. But that's okay, it's giving me time to have my snack. Nope, that's perfect. That's perfect. That's the parts of the product rule. Y prime.
Should be
Well, it was correct. I'm just
3y
gonna write it.
plus 3xy prime minus 4y times y prime.
Okay. Oh, these pictures are going to drive me nuts today. Honestly, I don't really care about the pictures, but the problem we're running into is when you guys are coming and going, you immediately are like throwing focus off. So it's going to be really hard to get things done. I get that you missed part of it. I can't do anything about that. Question? Okay. Are we okay with this line? And don't ask me about this line because you were gone. So basically, I'm speaking to the people that were here. Okay? Then, as soon as I took the derivative, I have choices. Because that line is the derivative, it's not like simplified or rearranged, it's just the derivative. I'm trying to find the slope at 1, 1, so I could put in 1, 1 throughout this whole line if I want. To be honest, if I were doing this problem myself, that's what I would do, because I would get to the final answer quicker. But sometimes you're just gonna be asked to differentiate, not at an individual point. So if you were asked to differentiate, that means we need to solve for y prime, or dy dx, however you write that. So I would keep every term with y prime on the left-hand side. On the left-hand side. Every term that's not y prime, let's get rid of. So then this would say 3xy prime minus 4yy prime equals 3y, oh, excuse me, negative. Negative 3y minus 1. And then like on the previous problem, since we are trying to solve for y prime, put your phones away, put your Chromebooks away. Like, this is all on top of everybody coming and going for pictures. You guys need to learn how to teach yourself to actually pay attention to things. It doesn't matter if you're bored. It doesn't mean you take out your phone to look at notifications. Just keep your stuff away. When we're solving for y prime, we have to have only one of them. So the way that you get one of them is you factor it out. So this would be 3x minus 4y equals negative 3y minus 1. What you're going to find that's really annoying on multiple choice answers for implicit differentiation is this information can be written tons of ways. Like this, that's correct. It could also be written with the negative symbol factored out and then written as 3y plus 1. And there's going to be all sorts of ways the answers can be written. These are really annoying to match up to multiple choice. And you're going to have to do it by the time you get to the AP test. We are purposely putting multiple choice on this test as well, so that you guys are starting to get experience doing it. But y prime, I just divide by the whole parentheses. So I'm going to do this like an AP multiple choice question would be. And they would factor out that negative symbol and put it in front of the fraction. And then this would be the top of the fraction, bottom of the fraction by what you divided by. And then it's also annoying because if you decide to add the y primes to the right and then solve it basically reversed, this answer is going to be totally flip-flopped. Same information, but totally negative. So there's all sorts of different answers that are all correct and equivalent. If we brought the y primes to the right, then that means on the left-hand side would be positive 3y plus 1. But on this side, it was negative 3y minus 1. So they're complete opposite info, depending on the side they're on. And then we would end up dividing by positive 4y minus 3x. Because if I factor out negative, there's a reversed terms.
In the second step, where it's 3 times or y times 3, right? Could you not just do y times 3 minus y 4 times y?
Whoa, say it again.
So in the middle of that second step,
Right there.
3y minus 4y, why couldn't you do that?
Oh, no. No. The plus and minus signs separate the terms. So this is a term, this is a term, that whole thing is a term.
Okay.
You can't just subtract the 4y. Because this isn't 4y, it's 4y y prime.
It's in parentheses.
Yeah, basically it's in parentheses even though they're not right. Okay, so this is the derivative. Could be lots of versions that are all equal. But it doesn't matter if we're plugging a number in anyway, the final answers would all be the same. So I'm plugging in 1, 1. So y prime would be negative 3 times 1 plus 1 over 3 times 1 minus 4 times 1. 4, negative 1, 4. This one, it didn't say at the top, find dy dx, right? So it doesn't actually matter. Go ahead. Oh, okay.
Wait, you go back?
Back. Down.
Yeah.
Okay?
How did you get 4?
3 plus 1 is 4.
No, but like, the negative sign
Oh yeah, I wasn't done. I was just reading the top. So the top is 4. Bottom, it ends up being negative 1. So 4 divided by negative 1 is negative 4. And then the negative sign up front makes it positive 4.
How come you don't just like, cause the.
How about this? Instead of me factoring out that negative symbol from the start, I could have just written the original one, which was negative 3y minus 1. And then that would have given me negative 4 divided by negative 1, which is still 4. Like, all the information we have can be written tons of ways as long as it all goes together. Oh, that would do it.
When you factor out the negative 1 to make it negative, average 3y plus 1 on top,
It only affects the top.
so only the top.
It only affects the top or the bottom, your choice.
Yeah, so is that just because it's multiple choice method like that, or should we write our answer like that?
No, there's like 20 ways to write the answer. Correcting is horrible. But, I mean, like, if you do your problem right, you get it correct. So, and I'm pretty good at, by now, like, I can identify alternative forms pretty quickly, so I'll know if you did it right. What? Oh. I was hoping you guys could try number 3 on your own. Now, notice this one is not asking you to plug in a number, just find dy dx, which is the same thing as find y prime. Believe it or not, the bigger the equation, the easier it is to find the answer at the end. Because there are less versions of the answer. So it'd be negative 2x? Yep.
Then you have to times it by x prime.
So yes, but it's 1.
Okay.
So if you recognize something as just a very basic derivative, like just an x, then you don't have to do a chain rule.
Okay,
But if you're not sure, chain rule always works.
that makes sense. Wait,
Negative x squared.
It's like saying negative 1x squared.
So it'd be negative 2x times
times x prime, which is 1.
What'd you get?
You're supposed to take everything that doesn't have a y sign up to the other side. So I think it's the same thing as you. I don't think you actually have to, I think it's just easy.
Yeah. Chain rule. Chain rule.
Oh, he did it right too.
You don't do. It's fine. You just do.
Is this? Oh, I see, it says five.
Yeah.
You can't, because there's no functional notation when the equation's not solved for a variable. These aren't functions. So you can't do function notation like you're saying. They can't label equations the same way when it's not function notation. Right. Okay, here's the number one mistake. Forgetting the y prime or the dy dx on the 5. Because it's more obvious to do the chain rule or whatever you want to call it on the y cubed and the 5y squared. This one, for whatever reason, right? Like your brain probably does this as 5x. Like, is that how you guys do derivatives in your head probably? Like you make it an x when it's another letter?
Yes, it is.
No, okay, well, you're smarter than me, but. So 5x, the derivative of 5x is just 5. So I know it's just a number. But you're dealing with a letter that's not x. So then that requires you to do chain rule on every one of them. So this one is like saying 5y to the first, even though you don't really read it that way. So you still do chain rule. You multiply by the 1, you get 5y to the 0 times, I'm going the wrong way. 5y to the 0 times y prime. So it's really easy to miss it or not write it on this one, but you still need to. Every time you're doing a derivative that's not an x. So having the x on the bottom of the fraction means that x is your variable or your focus. And every variable that's not x has the chain rule on every term. Somebody here was asking something. Okay.
Wait, why do you not add the 5 to the other side? Like 2x plus 5?
I can explain it to him.
It's because it's got the multiplier on it, so I have to factor it out first.
I mean, it's like, it seems too.
This is the only term that doesn't have dy dx.
I don't think it's y prime.
And then this one, if we, it didn't want you to plug in a number, but if you did, you just plug it in there.
That's why it's multiplied, so you gotta do product.
Every letter other than x. When it has the x on the bottom, That means X is your focus, X is your independent variable. Everything else is not X. So you're gonna have equations that have more than two variables. So that's why I'm saying it the way I am. Every variable that's not focus is treated as like a unit. You've asked me the same question 4 times now.
Have I really? I
Yeah.
don't know.
So I'm writing it as dy dx so that you guys understand it's the same thing.
Okay.
If you write y prime, that's the same thing as dy dx. I basically wrote dy dx because that's what the problem wrote about.
I don't know.
But it is the same thing.
It's too easy.
Oh, wait, we're done to, what time are we done? Okay, I guess it will not do the next one. You guys are more than welcome to try a couple of these as your homework. Don't go into the homework yet, probably.
So, this is.
Sure.
This is.
I already gave, you already have all the answers to them. They're posted with the assignment.